So let's start with classification of elements and periodicity and properties, right? See, first thing that you have to remember is you have to read line by line NCRT for inorganic, especially for inorganic, right? Start reading from today only. Even I refer NCRT for inorganic completely. So till now, so how many elements we have in periodic table? How many elements we have? So in total, we have 114 elements, right? In total, we have 114 elements. उसमें से कुछ few of them are natural and few of them are man-made. And recently discovered elements are man-made.
Sir? Sir, there are 118, right?
Acha, okay. Fine. That is fine. Okay. So 118. And approximate, I think 94 or something like that, naturally occurring and remaining are man-made, right? Something like that, no? Do you know the exact number?
No, sir.
Okay, that is fine. Okay, so like we have few rules to study about the these elements, because the number is so big. Like we have around 118 elements and like that. So we need to have some systematic way to study. So in that direction, couple of scientists came and they proposed their own theory. So few of them contributed up to some extent. Still their theory got failed because of the next theory. So we are not going to study each and every theory, but few of them will study. So first thing that we'll study is Dobereiner's law of triads. First, Dobereiner's, maybe spelling might be incorrect. Dobereiner's law triad. Actually, this man grouped three elements together and found that atomic weight of the middle element is the average of first and third element. So this is based on atomic weight. In the beginning, all scientists worked on atomic weight only, and all got failed. We form a group of three elements called triads. Having similar properties. And states that the atomic weight of middle element is the average of the atomic weight of first and third element. Right? Examples we need to remember. First example, lithium, sodium, and potassium. So what is the atomic weight of lithium? What is the atomic number? 3. Atomic weight? 7. Atomic weight? 7. And atomic weight of sodium is 23 and potassium is 39. You can see that 23 is average of 7 plus 7 and 39, right? So the atomic weight of middle element is average of atomic weight of first and third element. So you have to remember this line: lithium, sodium, potassium. So in objective question, they can directly give you. So which forms triad, which does not form triad. And next triad is calcium, strontium, barium. Next triad is iron, cobalt, and nickel. Right? Lithium, sodium, potassium, calcium, strontium, barium, iron, cobalt. Note it down. One more we can mention NCRT. In NCRT it is mentioned uh, chlorine, bromine, iodine. Chlorine, bromine, iodine. So lithium, sodium, potassium, calcium, strontium, barium, iron, cobalt, nickel, chlorine, bromine, iodine. But it got failed. Why so? Because it has drawback. So drawback one, it could not fit for many elements. It could not fit for many other elements. That's why it got failed. Note it down. Done. Karchit, Shreya,
Yes, sir.
again, your video is turned on. Turned on. Karo, jaldi jaldi. Okay. Next law was Newland's Newland's law of octave. What was this? Tell me, what was this? What is law say?
Similarity between in the periodic functions of the first and the eighth element,
Right,
like the
right.
musical.
Like the musical notes. So, like, um, like every eighth musical note like sa re ga ma pa de, sa re ga ma pa dha ni, and then again sa. 1, 2, 3, 4, 5, 6, 7, and 8 again, right? So every eighth musical note will repeat like that only. Like he observed that every eighth element will repeat its properties, right? But it happened before discovery of inert gases. Later on, it was observed that after discovery of inert gases, people observed that no, not every eighth element repeat its properties. Instead, every ninth element repeat its properties. So it was also based on atomic weight, based on atomic weight. So Newland, Newland arranged the element in increasing atomic weight order. And proposed that every eighth element repeats its properties. But it was not valid for elements having atomic number more than 20, like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And then 1, 2, 3, 4, 5, 6, 7, and then sodium, calcium, sodium, uh, magnesium, this is B, boron, this is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and chlorine, like this. But it also got failed. So reason was, drawback was, after the discovery of novel gases, it was observed that not every eighth element, actually every ninth element, every ninth element repeats its properties. So it also got failed. Note it down. Done? हो गया? Next point is Lothar-Meyer curve. Any idea about this? This was again based on atomic weight. IUC, Shreya, Arpit, any idea about this? Lothar-Meyer curve? No. Okay. In school, they might not have taught you, right? Mhm. Lothar-Meyer proposed a curve between its physical properties and atomic weight. He proposed a graph between physical properties like atomic volume, comma, boiling point, melting point, etc., and atomic weight. But atomic weight versus atomic volume, this graph becomes very popular. Graph between atomic volume versus atomic weight became popular. Became popular. And graph looks like this. On horizontal axis, he took atomic weight, and on vertical axis, he took atomic volume. And graph is somewhere like sinusoidal increasing curve like this. Sinusoidal increasing curve like this, like this. Right. Very awkward graph. And he said that uh, uh, see, these are the peaks, right? Or you can say crest. Peak or crest. So peak or crest. Peak or crest occupies alkali metal. Alkali metals like lithium, sodium, potassium, strontium, potassium, rubidium. So the peak or crest will occupy alkali metal. And this is known as trough or bottom. This will occupy something like this will occupy by transition metal. Trough or bottom occupied by transition metals. ultra D block elements. And the descending portion of the graph, this thing, see, descending portion means this thing, this, this, this. Descending portion of the graph will be occupied by alkaline earth metals. Descending portion of graph occupied by alkaline earth metals. And ascending portion of the graph like this. Ascending portion of graph occupied by halogen family, halogens. So this was his observation. But sorry, but it also got failed because of very there was not much use of this because it was very difficult to remember things, right? And user friendly, it was not user friendly. So you can mention drawback watch, lack of practical utility yet. Drawback you can mention, drawback, lack of practical, lack of practical utility, lack of practical utility and difficult to remember. Not to. अच्छे से नोट बनाओ समझ समझ के हो गया लिखा हुआ? आयुषी लिख लिया? आयुषी, डन? Okay.
Yes, sir.
Next is Mendeleev's. He was the first person, Mendeleev's periodic table. He was the first person who organized element in a proper way, in tabular form. But he also did one mistake. He also arranged in the increasing order of atomic weight. Mendeleev's periodic law, table, based on atomic weight again. And he was the first person who did this in tabular form. So you can say that first uh, or organized elements in tabular form. He proposed 18 groups, 18 vertical columns. That is, vertical columns known is called groups, and 7 horizontal rows, means period. He proposed uh, 7 horizontal rows called as periods, and 18 vertical columns known as groups. He arranged elements in increasing order of atomic weight, and he arranged elements in increasing order of atomic weight and shown that elements of similar property falls in same group, same vertical columns. He said that. And he also, he was very intelligent, and he also left spaces for the undiscovered element that time. Like, that time, whatever element was discovered, based on that, like, he thought there might be some other element that will be discovered in future. So for that also, he left a space in periodic table. That was the brilliant idea. He left vacant spaces in periodic table for the elements not discovered that time. जो एलिमेंट डिस्कवर नहीं हुआ था, इसके लिए भी इन्होंने जगह छोड़ दी थी और उनका एक नाम दे दिया. He gave a name, Ika. Like, aluminium, after aluminium, gallium was not discovered that time. So he gave a name, Ika aluminium. That was later discovered as gallium.
सर सेकंड पॉइंट में एटॉमिक वेट एंड के बाद क्या लिखा है?
shown,
अच्छा,
and he gave name to these elements like Eka aluminium. Later, it was discovered as gallium. And Eka silicon. Silicon was discovered, but germanium was not discovered. So later it was known as germanium. Eka silicon. And whatever properties he predicted after discovery of that element, everything proved nearly same. But again, like even Mendeleev's predictable fail. Why so? First, you note it down. I'll tell you. Done. But why it failed? Point is why it failed. So write it down. Drawbacks of Mendeleev's periodic table. Earlier was merits. Now it is demerits. He placed coinage metal. What are the coinage metals? Copper, silver, gold. जिनके सिक्के बनाए जाते हैं. He placed coinage metal in the, with alkali metal. With alkali metals. Right. Also, based on the properties actually. Also, he placed manganese. Manganese along with halogens. That is non-metal, but manganese is metal. And what is Mendeleev's periodic law? What is the statement? The law says that properties of elements are a state law. properties of elements are a periodic function of their atomic weight. यहाँ पे प्रॉब्लम हो गया क्योंकि अभी तक सारे के सारे तुम देखो एटॉमिक वेट के हिसाब से ही कर रहे हैं, एटॉमिक नंबर पे जब किया ना तब सही हुआ। तो ये तुम्हारा था मेंडली पीरियोडिक लॉ। It says that properties of elements are a periodic function of their atomic weight, but actually it should be atomic number. We'll study later. I mean, next, law.
सर पीरियोडिक फंक्शन ऑफ देयर एटॉमिक वेट का मतलब?
Based on their atomic weight, increasing atomic weight, their periodic, physical properties will repeat,
Okay.
right? Okay. Now comes Moseley's periodic law, or Moseley's, whatever you call it. Moseley's or Moseley. Moseley's periodic law. He said that he did on based on atomic number, and he succeeded. He said that Moseley's periodic law. He said that uh, physical properties in fact, he say physical and chemical properties, physical and chemical properties of elements are periodic function of their atomic weight. Sorry, atomic number. Atomic number. He performed one experiment. Moseley performed an experiment. He bombarded highly energetic beam of electron. Moseley bombarded highly energetic beam of electron on a metal surface on a metal surface and studied Moseley bombarded highly energetic beam of electron on a metal surface and studied um, frequencies of the X-rays ejecting from the surface, ejecting from the metal surface. So actually he plotted a graph between square root of frequency and atomic number. And he found that the graph came a straight line. So he said that atomic number is the fundamental character of the atoms.
सर ये क्या किया था उसने एक्सपेरिमेंट में?
उसने क्या किया गया था, एक हाईली एनर्जेटिक बीम ऑफ इलेक्ट्रॉन को बम्बार्ड किया था मेटल सरफेस पे। जैसे सरफेस पे लाइट फॉल करता है ना,
हाँ।
लाइट में तो लाइट का एनर्जी होता है एक्चुअली, फोटोन होता है लाइट,
हम्म।
फोटोन। तो वैसे ही हाईली काफी एनर्जी वाला इलेक्ट्रॉन बीम को फॉल करवाया मेटल सरफेस पे, तो उससे एक्सरे निकला। उस एक्सरे का फ्रीक्वेंसी नोट किया। उस फ्रीक्वेंसी का स्क्वायर रूट के साथ बताता हूँ। उस फ्रीक्वेंसी का क्या किया इन्होंने, एक ग्राफ प्लॉट किया, स्क्वायर रूट ऑफ फ्रीक्वेंसी एंड वर्सेस एटॉमिक वेट। ही फाउंड दैट एक स्ट्रेट लाइन आया बिल्कुल, थोड़ा एक दो थोड़ा डेविएट हुआ बट दैट इज फाइन। एक दो डेविएशन देखा गया बट वेरी इट वाज वेरी क्लोज। ही फाउंड दैट square root of frequency, so we can say that frequency was very closely related to atomic number. गलत लिखा, एटॉमिक नंबर। आया बात समझ में? याद करना है, समझना नहीं है तुमको इसको।
तो सर मतलब ऐसे इनबिल्ट कोई इक्वेशन मतलब कोई रिलेशन है एटॉमिक नंबर और फ्रीक्वेंसी के बीच में? लाइक
yes madam, yes madam, yes madam, and that relation is under root nu मतलब frequency equal to a z minus sigma. This was the relation he established, where nu is frequency, याद करना है। z is तुम जानते हो एटॉमिक नंबर, a is some constant, एंड सिग्मा को कहते हैं शील्डिंग इफेक्ट और स्क्रीनिंग कांस्टेंट। शील्डिंग कांस्टेंट और स्क्रीनिंग कांस्टेंट, स्क्रीनिंग कांस्टेंट और शील्डिंग कांस्टेंट। स्क्रीनिंग कांस्टेंट और शील्डिंग कांस्टेंट याद करना पड़ेगा। रूट न्यू इक्वल टू ए जेड माइनस सिग्मा। देखो, one suggestion I want to give you guys, in chemistry especially, don't apply your brain, whether you have or not does not matter. Just don't apply your brain, just remember everything in organic or in organic and inorganic, especially in inorganic. You just have to remember everything. रट्टा मारना ही पड़ेगा, there is no other way. You have to accept it as early as possible. इस मिसकंसेप्शन में मत पड़ना कि तुम बहुत इंटेलिजेंट, तुम्हारा मैथ फिजिक्स बहुत बढ़िया है, लॉजिक बहुत स्ट्रांग है, खटिया खड़ा हो जाएगा तुम्हारा। याद कर, रट्टा मार दो, मारना ही पड़ेगा। एक्सेप्शन केमिस्ट्री में याद करना ही पड़ेगा। So he also mentioned that atomic number is the more fundamental property. The more fundamental property. Now you there is the question, sir, how we can understand. So that's for your, this is for the sake of understanding. I'm telling you how they might have established the relation. I'm telling you, first note it down. हो गया बालकों?
सर 1 मिनट नीचे करना ना,
1 मिनट नीचे करना। नीचे में कुछ नहीं है मैडम जी।
फ्रीक्वेंसी
लो, लॉल, कुछ नहीं था नीचे। चले,
वो साइड में फ्रीक्वेंसी वाला।
मैं इतना हंसी मजाक करते हुए पढ़ा रहा हूँ ना इसको, क्योंकि ये बड़ा बोरिंग होता है पढ़ाते पढ़ाते। मैं खुद ही बोर हो जाता हूँ, मैं खुद ही भूल जाता हूँ बहुत सारा चीजें। इसलिए लाइट मूड में पढ़ाता हूँ। जब भी केमिस्ट्री पढ़ाता हूँ, इनऑर्गेनिक वगैरह, ऑर्गेनिक पढ़ाने का तो हिम्मत नहीं होता। थोड़ा बहुत पढ़ा लेता हूँ ऑर्गेनिक। ऑर्गेनिक डिटेल में जाने का हिम्मत नहीं होता। एल्कोहल, फिनोल, वो एल्कोहल फिनोल इथर वो सब नहीं होता है। उसके लिए तुम्हारे लिए अलग टीचर है, वो आएंगे पिक्चर में। नोमेनक्लेचर अगर पढ़ा लेता, उसमें कोई दिक्कत नहीं है। अभी वो
हो गया।
टीचर 12th में बिजी है। चले आगे चले। देखो, जस्ट फॉर श्रेयाज अंडरस्टैंडिंग, जस्ट फॉर अंडरस्टैंडिंग, देखो क्या होता है। यू नो दैट व्हेन इलेक्ट्रॉन like jumps from higher shell to lower shell, it releases energy. When a lower shell to higher shell, it gains energy. You have to give energy, right? So either way, like transition in electronic transition, we can say that in electronic transition, suppose any way, like N2 minus E N1, that is what is this? Actually, that is the energy, right? Energy of the photon. And what is the formula of energy of nth orbital? Minus 13.6 into Z square by N square. किसी को याद नहीं होगा। वैसे मैंने पढ़ाया नहीं एटॉमिक स्ट्रक्चर, थोड़ा पीछे अभी हम। आई विल टीच यू इन एटॉमिक स्ट्रक्चर, दिस इज द एनर्जी ऑफ nth ऑर्बिटल। श्रेया, यू मस्ट नॉट बी रिमेम्बर, रिमेम्बर नहीं है, ठीक है। तो पुट कर दो यार, n2 स्क्वायर माइनस माइनस 13.6 इंटू जेड स्क्वायर बाय n1 स्क्वायर इक्वल टू h v। You can notice from here that this will become minus minus plus, so 13.6 into z square you can take out, and this is like this upon h equal to nu. Now you can see that, suppose, see, you can write this in, this is nu and this is z square. Rest are, this is Planck's constant, this is n1, n2 constant thing. So nu is directly proportional to z square. So you can say that square root of nu is directly proportional to z. That's why. That is how he plotted. Understand? Square root of nu is directly proportional to z. नोट करो, हमने जहां लिखा है तो नोट करो खुद से। ऐसे मुंडी हिलाने से नहीं काम चलेगा। सर समझ गया।
सर वो EN2 है ना?
हाँ, एनर्जी ऑफ n2। हो गया, चले आगे। अब आगे मॉडर्न फॉर्म ऑफ पीरियोडिक टेबल, पीटी मतलब पीरियोडिक टेबल, इसको लॉन्ग फॉर्म भी बोलते हैं। तो मॉजुलेस का था ना, जो बेस्ड ऑन मॉजुलेस पीरियोडिक टेबल, बेस्ड ऑन मोसलेस periodic table. It has, I already told you that 7 rows.
मॉजले पीरियोडिक टेबल और मॉडर्न पीरियोडिक टेबल दोनों सेम ही है।
No, 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 no. मोसलेस के पीरियोडिक टेबल पे ही थोड़ा सा एनहांसमेंट करके, वैसे मैंने ना एक चीज गलत लिख दिया, तुम लोग करेक्ट कर लो नोट में। मोसलेस पीरियोडिक टेबल में, in Moseley's periodic table, there were only 9 vertical columns, 9 groups. By mistake, I have written 18 periodic table, 18 vertical columns. Based
मेंडलीव
on,
में
हाँ, most, oh, Mendeleev में
7 हॉरिजॉन्टल और
9 vertical column. But in modern form of periodic table, it is 19 vertical columns. इसको
7 हॉरिजॉन्टल है और 9 वर्टिकल है।
हाँ हाँ हाँ, in modern form we have 7 rows and 18 vertical columns. This is your groups. ये बात ठीक है ना? चले आगे, देखो जो पीरियोडिक नंबर है ना, सॉरी पीरियड नंबर represents maximum quantum number. Now, though, like, I haven't taught you this in atomic structure, but you must have studied in school, right? So you must be knowing that in a quantum number. Suppose period 1, it means that n is 1. So this is the quantum number. Period 2, n is 2. I said maximum. Period 3, quantum number 3. Period 4, quantum number 4. Period 5, n is 5. Period 6, n is 6. Period 7, n is 7. N is 1. It means that only one S. 1s. And how many orbitals are in s? Only one orbital, है ना? In one orbital you can maximum put two electrons. So maximum in this period we have two elements. In period 1, maximum quantum number is 1 and 1. So we have like 1s orbital, and there is only one orbital in s subshell, and in one orbital you can maximum you can fill two electrons. So you have two elements only, hydrogen and helium, n equal to 2. So in 2, so with principal quantum number 2, we have 2s and 2p. So for s we can have one orbital, and in p we have three orbitals, px, py, and pz. So we have total 1, 2, 3, 4, 4 orbitals. So 2 into 4. So maximum electron that you can fill is 8. So we can have 8 elements in third period. You can count. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then a noble gas in noble gas column. Neon, right? So we have 8. In second period, we have 8 elements. In third period, you can see, you can have 3s, 3p. But you will say, sir, 3d. No. 3d means like, we cannot fill electron in 3d here, because, in d orbital, electron is filled in n minus 1d. So when we'll talk about n equal to 4, in that case, we'll have 4s, 4p, 3d. Right? That is why 3s, 3p, again we have same. So again in third period we have 8 elements only. There are 4 orbitals only. N equal to 4. We can have 4s, 4p, and 3d. So in 4s we have 1 orbital. P we have 3 orbital. And in D we have 5 orbital. So we have 5 plus 3 plus 1, 9 orbital. So 9 into 2, 18 electrons you can fit. So we can have 18 elements in fourth period. In fifth, we can have 5s, 5p, 4d. So again we have 1 orbital, 3 orbital, and 5 orbital. Again we'll have 18 elements. In 6 we can have 6x, 6p, 5d, and 4f. So in this case we can have 1 orbital in s, 3 orbital in p, 5 orbital in d, and 7 orbital in f. So how many? 16. So multiply by 2. 32 elements we can have. But तुम लोग ये सोचते होगे ना कि sir, how do you decide कि like which will have like P, D, F? How? See, it is like NS, NP, N minus 1D, N minus 2F. ऐसे करके होता है. अगर N equal to, if you take 4, suppose 4, तो 4S, 4P, 3D, 2F is not possible. 2F होता ही नहीं है. D 3 से स्टार्ट होगा, F 4 से स्टार्ट होता है.
क्यों?
अब नहीं होता है तो नहीं होता.
हाँ, D3 से होता है और F4 से.
4 से. GH करोगे तो आगे बढ़ाती है. अगेन इसमें भी वही होगा.
ये ऑफ प्रिंसिपल है ना?
हाँ, वो सब उधर पढ़ा होगा. अभी तो हम थोड़ा तो अटेंडेंस में पीछे रह गए ना, हमारा क्लास अभी बीच में 1 वीक नहीं हुआ ना, इसीलिए. 6d 5f आगे करके फिर इतना ही होगा इसमें। अगेन इसमें भी वही होगा 16 इंटू 2 32 एलिमेंट्स। तो देखो दिस इज 2 elements 8 8 18 18 32 32. So this is called magical number. Magical number. I'll tell you how to use this magical number. 2 8 8 18 18 32 32. Seventh period is incomplete. Hmm. Hmm. अगर एक फॉर्मूला लिखना चाहते हो तो ये होता है कि नंबर ऑफ एलिमेंट्स इज 2 इंटू नंबर ऑफ ऑर्बिटल्स। वही किया मैंने यहाँ पे अभी।